Hello everyone, and welcome to Python Crash Course Part 1. In Part 1, we're going to go ahead and begin our discussion of Python by going over basic data types. Let me go ahead and show you where you can find the Jupyter Notebooks for this lecture series. Okay, here I am at the downloaded and unzipped repository. If you go ahead and go to the Python Crash Course folder, you'll see 3 notebooks here, or IPYNB files. We're going to be working with the Python Crash Course notebook. And if you click on that, you should see a notebook that looks something like this, and it has all the data types we're going to be going over. We'll start off by just going over numbers, strings, printing lists, dictionaries, booleans, tuples, and sets. We'll see how far along we can get, and later on we'll cover some more advanced features. I'm going to go ahead and start a new notebook here and set it ready to go. I'll go ahead and, in the view, toggle the head bar and toggle the toolbar just to get a little more room here. And again, all I'm going to be doing is typing through all the examples here and explaining the code as we go along. So if you ever need to reference something, you can just copy and paste from this lecture notebook. All right, let's go ahead and get started with basic numbers and arithmetic. Python has 2 basic number types. There is the integer, which is just something like 1, and then there is the floating point number, which is something like 1.0. So a floating point number has a decimal attached to it. And with either of these numbers, you can perform basic arithmetic as you would expect. So for addition, it's just a plus sign, 1 plus 1. And I'm just doing Shift-Enter here to run the cells. For multiplication, it's just an asterisk, so 1 times 3, just an asterisk like that. Division is just going to be a /, 1 divided by 2 is 0.5. And note that even though I put in 2 integers, I get a floating point out. If you're a Python 2 user, you'll have to make sure that one of these itself is a floating point number in order to get the same result I just did. For exponents, for instance, 2 to the power of 4, it's just 2 asterisks put together. So 2 to the power of 4 is 16. That is 2 times 2 times 2 times 2. Something else to note is that Python will follow an order of operations as you would expect, and you can use parentheses to actually clarify the order of operations. For instance, if I go ahead and type in 2 plus 3 times 5 plus 5, mathematic order of operations would actually declare the multiplication to occur first and then the addition. So if I run this, I will get 15 plus 2 plus 5. So 15 plus 7 is 22. If you actually want to say something like 2 plus 3 times the result of 5 plus 5, you can use parentheses in order to just clarify your order. So you can use parentheses in this manner to actually say 5 times 10, which will get you 50. The last arithmetic operation I want to show you is the mod function. So the mod function, or modulus as it's also known, is the percent sign in Python. And it basically will return what remains after a division. So 4 divided by 2 is 2 remainder 0. So when you run 4 mod 2, you'll get 0 as the output. 5 divided by 2 is 2 remainder 1, since 4 plus 1 is 5. And so you'll get out the remainder 1. And this is a nice way to check if numbers are even. So you'll know that if, for instance, 8 mod 2 returns 0, that 8 is an even number because 2 goes in evenly to that number. And it has remainder 0. Now let's talk quickly about variable assignments. A lot of times you'll want to pick variable names in order to assign some object or data type to a variable name. In Python, the assignment operator is just an equal sign. So you'll choose the name of your variable by just starting to type stuff out, such as var. Then you'll say equals, and then whatever object type you want to put in there. So for instance, we can put in 2, and then whenever I call that variable name var, I will get a 2 out. So for instance, I can say x is equal to 2, y is equal to 3, and now I can actually say x plus y and get out 5. I can also reassign x by defining it by itself. So I can say x is equal to x plus x. So that will end up resulting as x is equal to 4. And now whenever I call x again, it's going to be equal to 4. Meaning if I were to run that cell again, the x equals x plus x, every time I run it, it's essentially going to double the value of x. And it's going to reassign x as its old double value. All right, A couple rules about creating these variable names. They shouldn't start with numbers. So you can't say something like 12 var is equal to 12. Otherwise, you'll get a syntax error. And it'll warn you that it's invalid syntax. It'll actually give you the error. So you can't start off with numbers. And you also can't start off with special symbols. So you can't say something like $var. You'll start getting problems here. So you'll get errors with syntax. They should just start with a lowercase letter. If you want to chain together multiple words, you should use an underscore to separate them. So name underscore of underscore var. Other languages have you use a period to separate this. For Python, the proper syntax is to use an underscore. Now let's go ahead and talk about strings. So I'm going to make a comment by putting in a hashtag, strings, and anything with a hashtag in front of it, you'll notice it's colored differently, and it's because it's a comment, so it's just not going to run. So you can type in whatever here, it won't run. All right, let's go ahead and move on to strings. And I'm going to go ahead and zoom in a bit so you get a better view of this. And for strings, there's two ways of creating a string. You can use single quotes, and note how the color has changed, indicating that this is a string, or you can use double quotes. So this is a string. And then you can also wrap double quotes around single quotes. So let's say you have a sentence that says something like this, like, I can't go. So if you have this single quote, but you want to keep it inside, then you can just wrap this around double quotes. And you'll notice that that single quote gets retained within the string. So if you ever are having to deal with either you want a single quote or a double quote inside of a string, you can always just wrap it around another set of either double or single quotes, depending on what's on the inside. Okay, let's go ahead and talk about printing strings. I'm going to make a variable called x and assign it the string hello. For Jupyter Notebook, if I just type in x, it will show with out, and then it will show the quotes hello here. And this is essentially the same thing as if you were to type this directly into the console in Python. Just typing in the variable x will output the string hello. For Python, however, if you want to actually print the output of x, you'll have to pass it into the print function, which is going to be print, parentheses, and then x inside of those parentheses. And note now the difference here. I don't have that out indicator anymore, and I don't have the single quotes anymore. So this is how you should officially display stuff when you're trying to show the result in Python. You should use the print statement. Now let me go ahead and show you how you can format your print statements. Let's say I have a variable num is equal to 12 and a name equal to Sam. Now I want to actually print stuff based off those variables. I can do that with print formatting. I'll take a string and say my number is, and I will pass in a block of quotes or curly brackets there. And my name is, and I'm going to pass in another set of curly brackets. And then I'm going to say dot format. And note how it's colored here to indicate that this is a special method off of this string. And then what you can go ahead and do is pass in the variable names in the order you want them to be filled into these curly brackets. So if I just type this in and run this, what Python does is it reads that you have curly brackets here in your string and that you have dot format, and it will put them in the order you want. So it'll say, okay, num gets replaced here for these curly brackets, and name gets replaced here for these curly brackets. And that's a convenient way for you to use the variable names in your print statements instead of having to write out 12 or Sam all the time. And note that I'm actually not printing this yet. I'll have to wrap this entire thing around the print statements. So make sure your parentheses are balanced, and you can see just by selecting one of the parentheses, they get highlighted green. But now if I run this, this has truly been printed, and I no longer have that out cell. The other way you can use print formatting is to say, if we go ahead and change this up, you can pass in a variable into the curly brackets. So I can say 1 inside of the curly brackets and 2 inside of the curly brackets. And now that I've passed in these names, I can go ahead and inside of my .format statement, say 1 is equal to, and then whatever variable I want 1 to be equal to. In this case, I want it to be equal to that num, and then 2, I wanted it to be equal to name. And if I run this, I'll get the exact same result. What's nice about this is you no longer have to worry about the formatting being in the exact same order you want for the curly brackets. And you can continually put in more curly brackets. So more, and then you can type in 1 here again. And notice that Python can now search and put in your variables in more than just once. So it comes here, looks at the variable name, then goes to your format and checks, okay, what is the variable name there? So for instance, 2, it looks in here, says 2 is equal to name. All right, I'm going to fill in name over here, and then we know that name is equal to the string Sam. So it goes ahead and puts it inside there. All right, go ahead and feel free to post any questions to the Q&A forum if you're confused on any of this print formatting. But it's basically straightforward. Just put in your string, put in your curly brackets, and I would suggest that you use this method of passing in variable names because it's a little more clear when you go back, and you don't have to worry about messing up the order inside of this format call. Now let's go ahead and expand our topic of strings into indexing strings. If I have a string called s, and I'll say x is equal to hello, s here is just a sequence of elements. And in this case, each element is a letter. And I can grab specific elements from that sequence of characters by using this square bracket notation. And indexing at Python starts at 0. And this is something to note. If I say s square brackets at 0 and run this, it will return back the 0 element. So here we see s, it grabs hello, checks the 0 element, and then returns 0. Go ahead and see if you can grab the last O there in hello. Well, what would you do? You would say, well, what space or index is it at? It's at 0, 1, 2, 3, 4. You would put in 4 into these brackets and grab that O out. The other thing to note is you can also use what's known as slice notation to actually just grab slices of this string. I'm going to go ahead and type in, instead of s is equal to hello, I'll say A, B, C, D, E, F, G, H, I, J, K. I'll run that. And now what I'm going to go ahead and see is if I type in s of 0 right here in this brackets, I should get A back. Okay, that makes sense. Let's say I wanted to grab everything like A and beyond. Well, I can use colon notation, which is also known as slice syntax, in order to do this. I will say s of 0, pass in a colon, run this, and this colon basically says, okay, starting at 0, grab everything beyond it. And this notation works the other way around. I can say grab everything with the colon up to a certain index. So let's say I say A, B, C, D. So D is at index 3, 0, 1, 2, 3. If I pass in 3 here, this is basically commanding Python to say, okay, grab everything up to, but not including, index 3. This is sometimes confusing for beginners because they expect D to show up as well because it's at index position 3. But because indexing starts at 0, you should just think of this command as grab everything up to, but not including the character element at index 3. And we're going to be showing you more about slicing notation when we talk about lists, because it's the same sort of idea. And then finally, we can combine these two ideas here, as far as starting and grabbing everything beyond it, or grabbing everything up to, but not including a certain index point, by saying s, start at 0, colon, grab everything up to a certain index, such as 3. Now that returns the same result as ABC, but what I can do is replace these two numbers to set my start point and my end point. Let's go ahead and grab DEF. So D starts at index 3, meaning if I go ahead and replace this, I'm going to start at index 3, 0, 1, 2, 3, and then I'm going to go up to, but not including, G. So that's 0, 1, 2, 3, 4, 5, 6. So I'm going to say 3, colon, 6, run that, and I get DEF. again, it's just the index you start at, that's included, colon, which means grab all the way through, and then your last index is the index that you don't include because indexing starts at 0. So G is not included even though G was at index 6. Okay, we'll again reiterate this idea when we talk about lists, which is coming up right now. Lists are a sequence of elements in a set of square brackets separated by commas. So here I have a list, 1, 2, 3. List can take in basically any data type. So I can also have a list of strings, A, B, C, and there's no complaints here. I'm going to go ahead and make a variable called myList and set it equal to A, B, C. Run that. And if I want to add an element to the end of my list, I use the append method. I say my_list, append, and then let's say I want to append the letter D. I just run that, and if I check my list now it has appended that value D. And a list is also a sequence just like a string is, meaning if I want to grab the first item in a list, I can use the same bracket notation I did for a string, pass in the index I want, run this, and it will return the item at that index. So 0, 1, 2, where each index point is now separated by a comma. For instance, if I wanted to grab B and C, I can use the same slice notation we just went over. I want to start at index 1 and go all the way up to, but not including, index 3. So I'll say 1:3, and that returns B and C. I can also reassign positions using this index notation. So if I wanted the first element to be something different, I just say my_list, pass in 0 into those square brackets, and then pass in whatever element I want. For instance, I want that element to be new now. So if I grab my list, I see new B, C, D. Something to note here is that you can nest lists inside of each other. So I can say a list 1, 2, and then put in another list, 3, 4. So if I take a look at list, it's a list inside of a list. So if let's say I wanted to grab this 4 as just a single element, well, that's a list at index 0, 1, 2. So I pass in 2 here, and this returns another list. So let's say I want to grab 4, well, that is now at index 0, 1, meaning I can tack on another set of brackets, 1, and get the actual element 4. Let me go ahead and show you one more example of grabbing stuff from nested lists. You don't do this too often with lists that are very deep, but I just want you to get the idea of using multiple brackets. So let's say I have a nested list that looks like this, 1, 2, 3, another list, 4, 5, another list target. Well, I can grab the third or fourth element at index 3 in my nest list. That looks like this. Then I can set another one to go at index 2, 0, 1, 2. That's the target list. And let's say I want the only elements in that target list. Note it still has the square brackets around it. I just pass in 0, and now I have the string target. And if I actually want to print this string, I can wrap this whole thing in a print statement, and now I grab my target. You'll have an exercise where you have to kind of find something in a nested list, so make sure you understand this topic of these brackets kind of stacked on top of each other. All right, we'll go ahead and stop here for part 1, and coming up next, we'll go ahead and cover some more data types. In this lecture, we went over lists, slice notation, how to grab things from an index, strings, how to do some print formatting, basic variable assignments, and also just basic arithmetic. Okay, hope you enjoyed this lecture. Coming up next, we'll go over some more stuff. Thanks everyone, I'll see you at the next lecture.